All right, we're going to talk about square roots. And in fact, we're going to talk about the most basic version of square roots. That's when we have what we call a perfect square. A perfect square. What I mean by that is when I actually take the square root of something, I get a whole number. If I do that, then that number that I took the square root of is a perfect square. So for example, I'm going to tell you that 1, 4, 9, 16, ... are all perfect squares. And there are a whole bunch of them. There are infinitely many. More specifically, if I took the square root of 1, I get 1. If I get the square root of 4, I get 2. You see how these are whole numbers? We talked about whole numbers before. If I take the square root of something and I get a whole number, then it is a perfect square. Now let's make sure we understand what I mean by taking the square root. First off, this is the symbol. It's a radical. This means the square root. The square root means 2. Or in other words, what times itself 2 times. So what times itself 2 times. If you can actually take what we call the cubic root or the third root. That just means what times itself 3 times. And that would be with the 3 right here. Right? So it's a cubic root because you put a 3 there. It's a square root because you put, and in reality, you don't usually see the 2, but there is a 2 right there. Okay? That 3 and that 2, those are called indices. That's called the index. This thing and this thing. Just giving you terminology right now. What you usually will see, though, is that the square root is so common that you don't write this index of 2. Right? So if I ask you to do the square root of 4, for example, that is assumed to be an index of 2 right there. It's assumed to be. You don't even have to write it. I'm asking what times itself gives me 4. Well, 2 times 2, make some arrows and not equal signs, sorry. 2 times 2 equals 4. Because of that, this 2 is the square root. All right. I want to make sure we're clear, though, that I could also write this as -2 times -2. That also gives me a positive 4. And so -2 is also a square root. But it is so common when we are dealing with what we're dealing with right now, we only want the positive version. You might hear that called the principal square root. Maybe. It's a principal square root, I think. The principal root. That just means the positive version of it. So for our purposes here, we just want to focus on the positive, but I felt like if I didn't mention that you could also get a negative when you take the square root, when you try to do that in algebra, I don't want you to be shocked, okay? So just focus on this right here. All right, so if I were to look back at our problem over here, and I think we probably already know, what times itself gives you 16? Well, that's a 4. And I think we'll be good. I think the first 2 questions are like that, and then we'll get to question number 4. As long as I have a perfect square, I can just go ahead and do like I'm doing over here. I'm looking for a whole number answer. But 80 is not a perfect square. And so what we might have to do sometimes is later on in math, you'll actually simplify that so that you have a radical in your answer. But for right now, this question is asking us to estimate that. So I'm looking for the square root of 80. Notice that the calculator popped up. And you can click in the square root of 80, hit equals, and you get 8.944, blah, blah, blah. It says to round to the nearest hundredth. And so I'll look at this 4, and then I'll look at the 4 after it, or the number after it. Since that number is less than 5, I keep this 4 where it is. So my answer will be 8.94. And then that's just estimating it to the nearest hundredth. I think I have a couple of those in there. And then if you look at this, it's going to ask you to order these things from least to greatest. Just put all these things in a calculator and see what the number is and then move that around. I see that my time is about to run short, so I'm not going to do that, but that's what it's asking you to do. All right, thank you.